In this video, we're going to start taking a look at a little bit more with respect to functions. So we're going to take a look at how functions work with respect to input and output. And then we're also going to start taking a look at how we can analyze the graphs of functions. And so to be able to evaluate a function, essentially all you're going to do is just substitute a value in for x. So for in other words, f at -3 is going to be where we just substitute -3 in for x. And in this case, it's going to be equal to 1. So it basically means that in our function machine, if we throw 3 into our function machine, and we have the output for that is going to be 1 into our function machine f. So that's the way to kind of think about it, right? Now, we don't necessarily always have to throw numbers into our function machine. We can certainly throw algebraic expressions into there. So for instance, if I was to throw a -7 into our function machine, that would mean that I'm going to have a -7 plus 4, and then we could just combine the constants together, and the output for this would be a -3. All right. Not all of them are that quick. Some of them are a little bit more algebraically rigorous. And so we have this function g of x is equal to x squared minus 2x plus 1. And we want to find f at 2, which is pretty easy, right? Because that's just going to be 2 squared minus 2 times 2 plus 1. This gives us 4 minus 4, and then plus 1. So 4 minus 4 plus 1 is just going to end up being 1. Right? Now, for f at b plus 1, that's a little bit tougher because we have to substitute b plus 1 back in for every x. And so this is going to be the quantity of b plus 1 squared minus 2b plus 1 plus 1. And now this just becomes an algebraic sort of FOIL problem where we're going to multiply things out. Right? So this is going to become b plus 1 times b plus 1 minus 2b plus 1 plus 1. All right. Remember, with a square, you can't just distribute that through. Okay, that's illegal for you to do. So what you want to do is just turn it into a FOIL problem. And remember, you have your first, your outer, your inner, and your last with your FOIL. So b times b is going to be b squared. And then b times 1 is going to be 1b. And then you have 1 times b, which is another 1b. And then 1 times 1 is 1. Right? You're going to distribute the -2. So we have -2b minus 2 plus 1. And then the last thing you're going to do is you're going to combine all like terms. And remember, like terms are going to be terms that have the exact same variables raised to the exact same power. So we have a b squared. There's nothing else like b squared. You have 1b and 1b, which is 2b. But then you have a -2b. So these all cancel out. You have 1 plus 1, which is 2, but then you have a -2. All right, so this guy's cancel out. So all of that is just going to simplify into b squared. All right. One last example of substitution or evaluating these sorts of functions. We're going to find f at -3 and f at c minus 4. So we're going to say h at 3. And h at -3 and h at, so these should be actually h's. So just ignore that and make that h at -3 and h at c minus 4. All right, so h at -3, that's going to be 7 times -3 divided by -3 plus 4. 7 times -3 is -21. -3 plus 4 is 1. And so that's just going to wind up being -21. And then if we plug in h at c minus 4, that's going to be equal to 7 times c minus 4 divided by c minus 4, which is x plus 4. And notice what we can do is we can cancel out the 4's in the denominator, and we could distribute the 7 in the numerator. So this could be 7c minus 28 divided by c. Right? So that's just how you would go through and to be able to evaluate or to substitute into functions, right? Now, another thing that we can do with functions is if we have the graph of a function, we can be able to evaluate given the value of the function. function. And I'm going to zoom in just a little bit here. So for instance, if we had this function, and this is the graph of our function f, and we wanted to find f at 3, we're just going to go to 3 on the x-axis, which is right here. And remember, this is like an ordered pair. So if the input is 3, then the output is going to be the y coordinate. And right here is the point 3, 0. So the output would be 0 for this. All right, so that's what we're looking for. Is we're looking for the output. If we go to -2 on the graph, then we end up with this point, -2, -4. Right, so the output for this would be -4. And then if we go to the to where x is equal to 0, all right, so again, this is our input, which is x. This is our input, which is x. This is our input, which is x. Then the output, this point right here, would be the point 0.04. So our output for this would be 4. So it's really easy. Just look at the y value, and that's the output of a function. Same thing for this graph, right? So if we look at the point where 2 is, we go here, and this is going to be the point 2, -9. So our output for here is going to be -9. At -7, it's going to be this point right here. So this is going to be the point -7, and it lines up specifically with 6 on our graph. And then finally, right here is specifically the origin. That's the point 0, 0. All right, so our y value is going to be 0 for that. Right, so that's all we're doing is we're just going through and figuring out inputs and outputs. Okay, x's and y values. So again, this is an x, this is an x, and this is an x value on our ordered pair. And then this is a y, this is a y, and this is a y value. Okay, so we have inputs and outputs. Okay. Another sort of thing that we'd like to do is we'd like to be able to look at a graph and identify both the domain and the range and some intercepts for a function. All right. Now remember, domain is the set of all inputs or the set of all x values. The range is the set of all y values. All right. So for this one, now notice that if you were to continue to draw this with the arrow, this would go forever in both directions. All right. So if you have a domain that just runs infinitely, you're going to say that the domain for this is going to run from -infinity to +infinity. All right. For the range, the lowest possible value for the range is right here at the number -4. All right. So we're going to start at -4. And then the range just tells us all the values to which we're going to go up forever. All right. And notice that if you have an arrow, that means you're just going to go off to infinity. And so we have -4 to infinity. And remember the difference between a bracket and a parenthesis. A bracket means it includes our value, and the parenthesis means that it excludes. And we'll see a few more examples of this in a moment. X-intercepts are the places where it crosses the x-axis of the function or the relation. In this case, we have an x-intercept right here at 1. And then we have another one at -3. So this is -1, this is -2, and then this is the point -3. So there's 2 x-intercepts. We have one at +1, and then we have one at 3. The y-intercepts are the places where it crosses the y-axis. And notice that we have one right here, and the value for this is -1, -2, -3. So we just go down and we count that out. So this is going to be -3. If we wanted to go through and try to evaluate the functions, just like we did earlier at the beginning of this video, we could do that as well. And so if I'm looking for f at -1, then all I'm going to do is just go to the left 1 unit. So I go right here to -1, and then I just drop just like we did earlier a few moments ago. And so f at -1 is going to be -4. And then right here at this point where f is equal to 1, then the output for that is going to be 0. All right, so hopefully that gives you a good understanding as to how to try to work with the domain, range, intercepts, etc., with respect to the graphs of functions. All right, another example. So for the domain for this one, notice that there's no arrows. And if there's no arrows, that means that you're going to have a limited domain and a limited range for this. So the domain is all the x values for this. So notice right here, we have an x value that starts at -4. And then the last x value And if we wanted to, we could say that this is going to be the point -4, and right here, this is 5, 6, 7. All right, so it might be helpful for us to plot these points, and this is going to be the point 0, -9. So the domain for this function is going to be, now there's an open circle here, so it excludes these points. All right, so it's going to exclude -4, our x, and then it's going to keep going in the x direction until we get to 0. All right, so we have -4 to 0, but it includes 0 because it's a solid dot. All right, so we have to be careful with that. We have inclusive versus exclusive. For the range, we start at +7, but it excludes 7, and then it includes -9. And one thing to remember is that we should go from lowest to highest. All right, so the lowest possible value in our range is going to be -9, and it includes that value. And then the highest possible number is going to be just about 7. All right, it's like 6.9999999 forever. So we're just going to say 7 exclusive. All right, so remember, difference between parentheses and brackets. Open circle, you're going to use a parenthesis at that end. Closed circle, you're going to use a bracket at that end. For the x-intercepts, we're just going to look and see where it crosses the x-axis. And for us, fortunately, it only crosses at exactly one spot on the x-axis. In fact, it touches the x-axis right here, right? Or right here, excuse me. I circled the y-intercept the first time. And so this is going to be the point right here, -4, 0. And so the x-intercept is going to be at -4. Right? It's the only place it crosses. For the y-intercept, that's going to be right here. And that's going to be at the point 0, -9. All right. And so the y-intercept is going to be at -9. F at -1. All right, we're just going to go ahead and see where the function crosses, all right, and get our best guesstimate for this. And in this case, when x is -1, then it looks like we're right here at -8. Right, and again, we just have -5, -6, -7, -8. So it just lines up right here at that point. So that's our point. Now, f at 1, well, there's nothing here. All right, so at this point, we're just going to put DNE, or does not exist. And that makes sense because if you look at our domain, okay, x cannot be equal to 1. It's only all the numbers between -4 and 0. All right, so it doesn't make sense to us that we would have a 1 inside of our domain. All right, so if for some reason you get a value that is not in the domain, that means there's no output. One final example is if we have like this sort of structure, all right, and we're back to the arrows. So for the domain, we just keep going left forever, and then we keep going right forever. And so the domain for this is going to be -infinity to +infinity. For the range for this, we're going down forever, all right, but we're not going up forever. We're only going up to -3. And so for the range, that's going to be -infinity, and then we're going to stop at -3, but we're going to include -3. All right, you can clearly see that this graph includes -3. For the x-intercepts, we don't cross the x-axis at all, so there are none. But where do we cross the y-axis? Right here at the point -3. All right, in fact, we cross at this point 0, -3. If I were to ask what f at -1 were, then we just go ahead and we graph the point where f is equal to -1 on our graph, and that's going to be right here. All right, and we just drop it down, and that's going to be at -3. And then finally, when f is equal to 1, that's also going to be -3. All right, so this is the point 1, -3. This is the point -1, -3, where we circle this up, okay? And so, and it's okay to have the same value as an output. We just don't have two different outputs for this, all right? So we just have to be careful when we're doing this. All right, so that's all that we have for the graphs of our functions for now. And in our next video, we're going to take a little bit more of a look at some of the graphs of our functions.